Good afternoon, everybody. As Steve said, I'm Eitan Konigsberg. I'm a front-end software architect at the New York Times. And today I want to talk to you a bit about how we made nytimes.com faster and a few of the surprises that we encountered along the way. So most people know us as a news and media company, but this is a picture of our technology team. There's a lot of people. The day we took this wasn't even everybody. If you can find me in this photo, I have a 4-week complimentary subscription for you. If you can find me in here, I'll give you a hint. I'm wearing the same hat. But I really think that when you think about web technology, we're referring to a lot of terms that really originated in print. So above the fold, which is a newspaper term, when you fold a newspaper in half, it's what you see, the first thing you see when you encounter the newspaper. Most typography-related issues originated in print. So I think that the New York Times is a real interesting blend of technology and old-style journalism, and we bring it together on the web in really interesting ways. So I'd like to think of us as a technology company in addition to news and media. So I want to kick things off with the performance golden rule. I love quoting people while they're in the room. Steve said this, I think around 2007 or so. 80 to 90% of end-user response time is spent on the front end. Start there when you're optimizing. And why do I bring this up? This is sort of the reason velocity exists. So I want to point out that it wasn't always this way. And before we were introduced to this enlightenment, the new way of dealing with web performance, where was everybody focusing their performance? On the back end is really the answer. And the reason I bring this up is because the New York Times went online in 1996, in January to be more specific. This is a screen grab from the web archive from November of that year, but this is what our webpage looked like when we first went on the web. And it's basically an image. It was an image map. You clicked on parts of the image, it would take you to various parts of our website. I don't know if you can see it. There's a low graphics link just below it, so apparently this was the high-end graphics version of the page. And even better is the line below that says, please open your window to the width of this line of text. So any responsive experts in the room would love to have all their users size the browser exactly where they want it. This is what we were asking people to do back in 1996. So back then, in order to be fast, we were focusing on the server side, and our answer to this performance issue was to have static pages. And we all know that if you do less processing on the server side, it meant that you could return those bytes to the wire as fast as possible. You don't have to have a lot of significant caching when you're doing this, right? You're just reading it off of disk and sending it over the network. But in order to scale it up, you have to have a ton of servers, which is what we actually had to have. And this handled traffic spikes rather well. So on September 11th, 2001, we handled that traffic spike. When the plane went down in the Hudson River a few years ago, we handled that traffic spike with this setup. And so we were performing really well, and we were very happy with it. We were able to introduce a certain amount of dynamicism to our pages through this proprietary language called context. And context looked like HTML tags that were interspersed among regular HTML. And there was a compilation step where we would turn this HTML context hybrid document into a binary that we would execute. And we had the special server software that executed context. And it was designed to compile and also execute really, really quickly. And we were able to achieve certain dynamicism because context server maintained connections to databases. And so we focused on performant database queries, and we were able to return something really fast. And it really was fast because we were interested in switching away from proprietary towards something like PHP. And when we did a head-to-head testing, context and PHP, there was really no competition. Context was always outperforming PHP in a live rendering test. And so we ended up having to relegate PHP to simply doing server templating. Context had to remain around in order to keep this dynamicism, which we couldn't use PHP for. So now we had this hybrid of HTML and context, and we've introduced PHP to create the entire thing, which is a crazy setup. And we ended up creating a monster. That's my dog, Hopper. She's not a monster. But when you scale this up, we had 1 million static pages on disk today. And the only way to change them is to publish them again. And it would take approximately 90 days to republish all of that, all 1 million pages. And that's even putting this process into the background so it doesn't interfere with news as it's happening today. So clearly we can't do this for every time we change code. We're not able to take 90 days for a change to go live. I don't think anybody would sit for that. And so in practice, we hardly ever republish these pages at all. So things get even worse because of that. Every time you make a change to one of these pages, this page template, you're making a new variation of it. So if you introduce a new script tag on January 1st, everything that comes after January 1st has one extra script tag. Everything that came before had one fewer. And so older pages are never updated. And if you extrapolate this over 10 years of development, we've introduced a ton of technical debt. We have no idea how many variations we've created just by making tiny tweaks to our code over the last 10 years. And as you can imagine, this is a huge nightmare. We really can't get a grasp on how bad the situation really is. So when we talk about web performance, we tried, we really did. And having an unknown number of these permutations, these variations of our pages, made optimizing front end really impossible. So we would combine files together. And we found out that when you did that, we couldn't remove the old references from old pages. So those files still existed and had to be served, and these pages would break if we just emptied out the file. So we were stuck. Every time we made a new variation, we couldn't really remove old code. Our download sizes had to increase because we couldn't change the markup. So every time you made a tweak, you would introduce a change and say, oh, I want this to work with this HTML version, but I know that we had these HTML versions before, so I had to make sure that they can all work together in the past without any changes. So our download sizes would increase as we just added more code to handle more cases. And then we wanted to have good caching, but we had to keep our cache time to live really low because, again, since we couldn't change the HTML at all, in order to get files to pick up the changes we've made to them in a timely manner, we wanted them to check somewhat frequently. So in the end, every time we tried to do something that was a performance best practice, we were making things worse and not better. And this leads us to our first surprise, that having a lot of static pages is a barrier to web performance optimization. And you're probably thinking, isn't that obvious? And you're right, it really should be obvious. And so why was this a surprise to us as we were going through and looking at how we were going to optimize our website? So this isn't really often mentioned in performance discussions. I've come to a lot of Velocity conferences, and it's sort of an assumption that people make about why would anybody create 1 million of these static pages, right? If you have a small site, it's maintainable, but why would anybody let the problem actually get so bad? And it really didn't become an issue for us right away, and for a few reasons. One is that not every page on our site is designed to live forever. So if you think of an article page, we're telling a story that's current events. It's frozen in time. No one has to change it unless somebody makes an edit to it. So those pages live forever. But something like our homepage, nytimes.com, is something that's reflecting the current events and literally current to 15 minutes and sometimes more frequent than that. And so we were republishing that, and that got around the republishing problem. The page really wasn't static in practice. And then, of course, newer articles are trafficked more frequently as people are trying to figure out what's going on now. But things in the past, people do research, but it's sort of a long tail, and it gets a lot of traffic on current pages. We could optimize them and save people time on what they're viewing now. We already had a ton of permutations of these pages, so making a few more really wasn't going to hurt. And then there really wasn't a practical alternative, and when I say practical, I mean internally. We had to organize as a company to avoid this problem. We were so used to doing business in a world of static pages that we weren't able to get together and solve this problem. So we didn't have another option. We were designed to work with static pages, and so that's what we were left with. So I want to do a force reload here, the browser command to do a force reload. And in 2013, we were presented with a very rare opportunity. Our product group gave the technology team a pause on new product development and allowed us to focus and deal with our infrastructural debt that we had accrued over the last 10 years. And if you work for a large company, this may not ever happen at all. It's very rare. And when it happens, you want to take advantage of it as much as possible. So we looked at our entire process and treated nothing as sacred. We looked at our infrastructure. We looked at how we configured our servers. We looked at how we organized our code, how we developed it, how we built it, how we deployed it, and more. Nothing. No assumptions were made about how we should be doing business. So we decided that we needed to deal with the static page problem, and we've decided that going dynamic is the only way forward for us. So we're slowly migrating all of that static content into databases so we can have a dynamic setup. And this is going to be ongoing because the further back you go, that permutation problem, we need to be able to structure the data in a way that we can template it in a sane way that fits our design today and also handles a lot of the hacks and things that were done in the past when the web platform didn't support what the newsroom wanted. So some things are going to become dynamic a lot sooner than other things. And so we actually still use PHP on the back end. In order to hide some of the slowness that we encountered when comparing it to context, we use Varnish to cache that. And we get great time to first byte with Varnish. We're really thrilled with how well it performs. It's really, really quick. We have a very simple caching strategy. We push most of the client customization code to JavaScript on the front end. And so the story doesn't change unless somebody changes it. So we end up in a very simple caching strategy. You take the story, you put it in cache, and if it's not accessed in a while, it'll eventually drop out. So things are very simple on the server side. Which leads us into our second surprise. And now that we've started over, we found that having a performance improvement was mandated as part of this new redesign that we were doing. And this was a surprise because this is the first project that we had ever done where upper management had supported a performance goal. And as a performance champion, this is probably the crowning achievement of anything that you're doing at your company, is to get somebody on board who will back you up and make it a requirement of the project. So why all of a sudden? Why in 2013 when we redesigned the site did we have a performance goal as part of the project? We had never done that before. And there are two major reasons. One, some of the search engines said that there was a factor in search engine optimization that the faster your website, the higher your ranking. And when you're a media company and you're looking at your competitors and Google and Yahoo and Bing and various search engines, you want to be the highest ranked item. That's going to drive the most clicks to your site. So the person who actually got this to be a factor of success for this project was our search engine optimization product owner. So he was in the ideal position. He was sold on this point, and I'm really glad that happened. The other thing is we started charging digital subscriptions. We started selling digital subscriptions to all of our content online, and we became an e-commerce site. And you hear it again and again at Velocity and other places that the faster your website, the better your sales can be. People want to buy a quality product, and performance is a huge aspect of people's perception of quality. And so we became an e-commerce site, and it became urgent that our site felt snappier. And so the way we accomplished this was to set a really conservative goal. And we wanted to be a certain percentage faster when compared to our old site. And the reason we kept it kind of conservative is we wanted to have an attainable goal. We were talking about all the things we could do to be faster, but when you're a large organization, you're not sure where you're going to end up as you do this. So we had to do something that was attainable, but also low risk, that we could still ship our product at the end of the day. And as a spoiler alert, we met our goal and more. So where do you begin? You have a clean slate. You have a blank page. Where do you start? We're looking at web performance optimization. How do you begin to design a page from nothing? And it's really difficult because there's a little bit of conflicting advice out there. And if you look at some of the original rules about how to keep your web pages responsive and fast, you look at things like reduce your number of HTTP requests, and that all makes sense. The fewer things you have to download, the better. But we discovered later that you can't reduce it all the way to 1. The browser will download things in parallel, and you're not taking advantage of that. So you can't reduce it all the way to its extreme. And in a similar vein, when you're combining files together to reduce your HTTP requests, in the future, with an upgrade to the HTTP protocol that I still think was slated for this year for final spec, doing so is really an anti-pattern to combine files together. What you really want to do is to keep them separate so you can prioritize what you send back to the browser on a more efficient connection between you and the client. And then additionally, you want to set long cache timeouts, and we have all this legacy code, and we found that those two are in conflict with each other. So we have a new code base that really doesn't help that much, so we wanted to really solve that problem. The other piece of it is this notion of tools, not rules, that you have a product, you measure it, you inspect how you're doing, you find the slow parts, and you improve on it. The caveat to that is you have to have a product first. So we're starting from nothing. We don't have anything that we can measure and inspect, so that doesn't really help us. So we really just had to stick to fundamentals and overhaul our site from the basest of requirements. So we use require.js to load our JavaScript in a non-blocking and asynchronous way. And what we really need is one blocking script in the head in order to download require.js and a few other things to make that all work. The reason it has to be in the head, right, one of the best practices is to move your scripts to the bottom. The reason it has to be in the head is that our pages are really a hybrid between what our technology teams do and what our newsroom technology teams do. And they make these fancy interactives that are embedded at the top of the page. And they have to make use of our frameworks, and we have to have them available to them at the beginning of the page load. And it's really weird making a page that's designed by two different technology teams with different interests. It's an interesting challenge. And if you're interested in helping us solve that, come work for us. We created a new modern build system to concatenate minify files. If you've made a site in the last 5 years, you've probably been able to take advantage of something like this. We never had this, and it was something that we really needed to do to be fast by default, that we needed performance to be a downstream process to what developers were doing. Finally, we implemented a new caching strategy. This is a best practice. We put a build timestamp in the URL of the file that we've created, and that timestamp is inserted dynamically on the server side. So every time we make a code push, every time we change the build ID, a new file is downloaded, and we can set a really long cache timeout on it because we only want them to download it when we change the code. And then the other half of what we were trying to solve was our advertisements. And it's mentioned a lot. Ads are a real bottleneck in terms of performance. So this was a worthwhile investment for us because we found it was the significant factor in what was keeping our pages from being fast. So before the redesign, the ads were treated as part of the markup that we were generating. They were first-person HTML embedded right next to the code that we were writing to design our website. And it would block rendering. They would load JavaScript, they would load CSS, they would load Flash, they would load videos, and these things could really slow down the rendering of our pages. So it was really critical that we found a way to solve this problem. We found that all we had to do was inject the ads into iframes, and this worked really surprisingly well. And if you want the details of that, I blogged about it. The slides will be available after if you'd like to. You don't have to copy down that link. And there was a minor issue with it. We found that ads that navigated inside the iframe that we put them in would add history in certain browsers. And that was really the nature of the blog, was to offer a solution to that. But this allowed us to hit the DOM ready event really quickly. And we were really happy. Once we took the ads out of the flow, our pages really sped up like crazy. So our third surprise is that sometimes you have to slow down to seem faster. And it really originates in the sense that you don't want to have things moving around while the page is loading. The perception of that is so awful that you really need to make sure that things are settled as much as possible while the page is loading. So the ads are really the reason why we had this shifting around. It's preferable to show an ad above the fold, right at the top of the page as the page is loading, because you can maximize visibility of this ad. However, if no ad was present to display, we want to use the entire width of our screen for the content. We're very proud of our journalism and our photos and those types of things. We love to use the space to have it all fit. And as a bonus, we wanted to introduce using the newspaper fonts for our headlines to make everything look like it was print. And so if you're familiar with how fonts work, browsers differ on what they do with text while the font is loading over the web. Sometimes they'll show a fallback, sometimes it'll be blank. So this notion was really obvious as things were shifting around due to the fact that the font was also changing the size and height of the headline. And so if things were fully asynchronous, things would shift. If we were inspecting to see whether we had an ad to draw, things would shift around, and it actually looked and felt slow. And it was really difficult when we made this new site, and it actually felt really slow. So just to demonstrate what I'm talking about here, I'm going to show you two variants of our article page. This is a recent article. Serena Williams won the US Open. This is a variant one. That big white space on the side there is where an ad would go. I removed the ad from this particular image, but there's space on the right-hand side of the screen here for an ad to show. And this is the second variant where there was no ad to draw. And so we moved the photo from the top of the article to the right and started showing the actual body of the article at the top of the page. So our initial solution to deal with this problem of content shifting around was to request the ad synchronously. I know. So we had to inspect the response that we got back from the ad request to see if there was an ad we wanted to draw there. And if there was, we would add a class to the HTML element of our page, and that would tell our CSS to make room for the ad below, and then we would continue loading the page. In order to do this, you have to intentionally have a blocking script at the top of your page, which makes me scream in frustration that we ever had to do this. It's very frustrating to introduce a synchronous script to your page load when you're trying to be fast. But while things slowed down, things didn't shift around. And this made everybody feel that the page was really snappy, that we had accomplished what we wanted to do. We introduced a slight delay, a synchronous script, in order to accomplish this. And I actually have an unexpected surprise here, was that in between since I proposed this talk and now that I'm giving it, we've changed our approach. We found a different solution. So when I was drawing this up, something was true. It's no longer true anymore. We came up with what is an even better solution. So some of the time we make room for an ad, and the rest of the time we use the full width. So it's entirely based on a certain percentage, and so X% of the time we show an ad, the rest of the time we use the full width. And this allows for both goals. It prevents the content from shifting around, which is what we set out to do in the first place, but it also maximizes our ad placement. And so because we've separated the decision of when to draw the ad above the fold from actually whether there is an ad or not, we can be asynchronous again. And there's a slight drawback. Sometimes you can make a space for an ad that never shows, or you can use the full width of the browser and you never show the ad that you wanted to, and you have to tweak the numbers to find out a solution to minimize this scenario. But what's really exciting about this is that we could get rid of that intentionally blocking script that we had introduced before. And so here's a graph of when we made this change, and I've highlighted it with a little green arrow there. That turns out into a 10% speed up just from that one script tag alone. That one decision that we had to make in a synchronous way blocked the page enough. So we were hovering around 2 seconds, and we got about 300 milliseconds back. Really happy with how that worked out. And this is from New Relic, and it's been really great in terms of keeping track of how everything is going on our front end. So I want to talk about what we're planning to do now. Now that we have a site that we can iterate on, we can do the tools not rules thing, and we can start measuring our performance. So I want to talk about some of the things that we can actually iterate on now. So the first thing is smoother animations. We introduced a lot of really fancy things to our pages, and they can often not perform very well, and things feel kind of sluggish. We have scroll event listeners for various business reasons, and those are causing a lot of jank as you're scrolling down the page. So we're exploring patterns to use request animation frame to get around that. We want to promote some of our fixed position elements that we introduced to the GPU. And we want to optimize some of our code paths in order to achieve higher frames per second. And some of the challenges to this is it requires refactoring large portions of our code. So when you've just built a fancy new product, the last thing you want to tell somebody is that we're going to have to make tons of changes to it again. So there's sort of a challenge in that we accomplish what we set out to accomplish, and we don't get that clean break again to start over. So we're going to find a way to do this on the fly where it's the least amount of effort for the biggest gains, and that's going to take a little bit of us figuring out how we're going to do that. The second thing is memory management. So as you know, the New York Times has a lot of content, and we load it all up onto our pages now on the client side, which is something we hadn't done before. And we're actually approaching some of the memory limits on mobile devices, specifically tablets. And when you run out of memory, the browser on the tablet crashes. So it's not something you want. And we've identified that there are plenty of candidates that are retaining too much memory. So one of the challenges to working with memory is that the tools are really complex. And I don't speak for everybody, but I never was trained as a memory profiler. It's not very common for front-end developers to know how to do those things, so we're all trying to figure this out and learn how to do it together. The tools are getting better, the graphs are getting great, they're easier to follow. But sometimes memory issues are really subtle and they're really hard to track down, and sometimes you just need an expert to really help you figure that out. So we're looking into how we're going to do this and figure out if there were really subtle memory issues. It takes a lot of time to figure these things out, so it's, again, something we're exploring. And finally, we want to focus on the critical path and above the fold content. We don't want to shift things around too much, so we really want to focus on that experience above the fold. So we need to inline our critical CSS, which is, again, something that's challenging for us to do just in terms of how we've written our site. And then lazy load the rest of our resources, and the challenges there are the editorial desire to put infographics and slideshows and really interesting things above the fold. And those things they're applications in and of themselves, and so they need to execute above the fold. And we also need to try and keep third-party code out of the head tag. We have to use a bunch of third parties to compete in our business, and so we have to have them on our pages, and we're trying to find a compromise where they can do what they need to do without impacting performance for our clients. An additional challenge is the ability to do A/B testing, to test variants of our web pages, and if we do all that on the client side, if we have to make any changes in the browser to test variations, those decisions have to be made up front, or else content's going to hide, shift, and move around, and it's not a great experience. Some other things that we're looking into, HTTPS, there's a lot of interest in the New York Times becoming HTTPS by default, But there are some really huge hurdles that are holding us back from actually making that possible. The static pages are really only a tip of the iceberg. I can't really go into all the details up here. If you're very interested in HTTPS for the New York Times, you can come speak to me. I'd love to talk about it. We're looking at the picture element. This is brand new. There are some caveats with it, but we have a new responsive site. We're loading images in a really inefficient way right now. We have to scale them down from the best possible size that we can. And so we would love to be able to automate that a bit better. So you're not downloading large images that we end up making smaller just so that it can fit on our design. In a similar vein, we're looking at web components. We're following this very closely, not just in terms of how we're going to have to write new web applications in the future, but we're interested in seeing whether we can use this to solve some of the ad issues that we were encountering, the scoped style rules, the templating, even new script contexts. There's some interesting stuff there. We're following that very closely to see how we can make use of that on our site. And pretty please, Service Worker, if there are any browser makers in the room, please bring Service Worker to the browser. When you have a company that has spent over 150 years doing a print version of their content, offline access is a real big selling point. That you can read the newspaper on the subway, but you can't use our site on the subway. So we're really interested in trying to bring that experience offline as well. So before I close, I wanted to just mention that the New York Times has a great developers program. We have a developer portal where you can find information about a lot of upcoming events that we have. We bring in interesting speakers. These things are open and available to the public. We're 2 stops away on the E-train, so if you're here, maybe you can make it to some of our events. I want to also point out that our developers and technical teams blog about things that we're working on, things that we're reading, interesting things like that, and you can find that on open.blogs@nytimes.com. You can follow them at NYT Devs, and other talks that we've done are available on SpeakerDeck/NYT Devs. Yeah, thanks very much. So I talked a little quickly, but I do have some time for questions if anybody wants to come up. And I've been asked if you can make your way over to the microphone here in the middle of the room so that they can catch it on the recording. That would be great.
The program pause that you mentioned, going through a similar thing at my company. How long was the pause, and how long did you have the plan for the pause or the outage?
Of course, when you're having a conversation where you're trying to convince people to take a break from their regular product development, it's going to be an interesting conversation to try and request as much time as you think you're going to need, and whether you're going to have enough time to do what you want to do. We took an extended pause. I can't say exactly how long. But the goal of it was to really solve those 1 million static page problem, and that took a lot of time. And we started working on this in 2013, and we didn't launch our redesigned site until 2014. So there was product development, it was going on, but it was very minimal, and we were trying to stop moving the goal line so that we can keep up with new requests as soon as we introduce something new. And I have to say that as soon as we did launch our initial redesign and replatform of all of our stuff, there were tons of product requests waiting to go out the door. So you get a pause, but then you also have to work twice as hard as soon as you do in order to accommodate that.
Everyone that I've talked to who loaded ads asynchronously saw a 5 to 15% dip in ad revenue. Did you see something like that? And if so, how did that go forward within the organization?
So I don't think I know exactly if there were any impacts to ad revenue specifically. We actually, it's a little more complicated than how I described it. We have a 2-tier ad system where basically if we don't know anything about the ad, we drop it into an iframe and let it do what it's going to do. So if it's going to break out of the iframe, it's going to do that on its own. The real benefit the iframe gives you is to prevent document.write from blowing away your document when you're working in an asynchronous way. We also had this notion of, we call it a trusted ad, but there are certain ads where we work very closely with the vendor. If we know that they're using best practices in terms of loading asynchronously, we can load them outside of an iframe, and they get the same experience that they're used to. We just have to know that they're not going to break our pages when we embed them on the page. So we have this program. It's managed by our ad operations team, and it allows them the flexibility to make sure that their ads work according to our standards, but also can maximize revenue for both parties. Any other questions? Steve, more?
Web Components doesn't support document.write. It just doesn't do anything. Is that going to be, how are you going to do ads in Web Components if that's the case?
That is a good question, and I don't have a good answer. I'm interested in seeing how ads can be injected into a web component to display them. If they don't work with the web component, we may not be a feasible solution, which is why we're keeping a close eye on it. But I think that the benefits of the template tag and scope style sheets and the notion that we can basically sandbox an ad inside of a component would be really compelling. Maybe we'll have to have the component be an iframe internally. Maybe we can do that.
I agree with you. I think Web Components should support document.write. Alex Russell, one of the key creators of the idea, is speaking here, I think, tomorrow afternoon. And I suggest you talk to him and encourage
Maybe I should ask
them
him
to support document.write.
Ask him that question and hopefully get an answer.
Can you say more about the hurdles to adopting HTTPS?
Sure. So the question was if I can talk more about some of the hurdles to adopting HTTPS. It's tricky. We have a lot of, we've organized to go dynamic. Sorry, let me start there. In order to be dynamic, we've created a bunch of APIs that we use internally that get our content moved around. And the APIs make assumptions in terms of what our host name is and what our protocol is. And so we have a number of things that basically are ignorant to what the protocol of our pages are. So in order to flip the switch, if we were to do that, everybody would get a redirect from HTTP to HTTPS on every single page view, which is less than desirable because the browser has to negotiate an SSL connection on the second round trip instead of the first. So that's a huge part of it, and that's organization-wide. There's a number of things that we're looking at and auditing and trying to figure out how to achieve that assumption. Additionally, again, when our web platform doesn't support a certain amount of functionality, our newsroom producers are able to write HTML themselves, and if they want to link to a fancy image, say during the political season or something like that, they often will hard code their host in this block of HTML, and we don't have that in a structured way. So using that is often a problem, not just in terms of HTTPS, but cookieless domains, things like that. It's really a challenge, and we've been doing this for a very, very, very long time. And so there's a lot of content in order to switch our site over. There's a huge amount of processing that we have to do to figure out organization-wide how we're going to make sure that the protocols are not assumed anymore, and that we can figure out how to automate switching to HTTPS. That's usually the biggest hurdle. It's just the sheer amount of content that we have that assumes HTTP. Yep. You both can go.
Can you talk a little bit about your A/B testing, and is that server side or client side, and how do you track through
the question? So you can hear the question about A/B testing. We currently do our A/B testing on the client side. We send our current tests from the server to the client, but JavaScript basically is doing all the work using classes on the HTML element and a queryable interface for JavaScript to determine which things to turn on and off. We have a strong interest in pushing that server side. It's going to complicate our caching strategy a little bit, but we're very interested in seeing how we can do both server side and client side A/B testing.
Hi. So I'm curious about the inlining the CSS at the head technique. I'm aware of it from talks from Igor. But I never was able to get it to fully work within a team. It just seems like a maintenance nightmare to actually get what's above the fold as you keep, even if you have A/B tests, things like that. Curious if you guys have a process for that, or if did you actually end up implementing inline CSS at the top, or?
So we haven't implemented inline CSS yet. It's something that we're looking into very closely, and I actually have similar questions about how you determine that in an automated way. What is above the fold, especially when you have to render the page in, say, a headless browser such as Phantom.js in order to determine and cycle over all the elements that are in view and create your inline style sheet. Since we have a dynamic site, we have to make sure that we can run that in whatever our build system is in order to create that. But there are automated ways especially in Grunt, and I'm sure in Gulp as well, that can do that in an automated way. And I would love for it to be downstream from what any developer is doing, that we just kind of put on the page what we expect and have our build system figure out what needs to be there. I'm also not sure, related to the prior question about A/B testing, if we have to do different variants. How do I tell an automated tool that I need both variants in there, especially if the first time through they weren't in the test and they didn't get it? So there are a lot of open questions. We haven't done it yet. We've started to look into it and see how we can optimize that flow above the fold. That's a really good question. I think that it's not flexible enough right now for what we need, and we got to figure out how to do it.
A few years ago, when you guys were switching to Varnish, you've written a long blog post discussing all the coding involved in that, coding for Varnish in particular. Loading ads, why is that? Have you guys considered that as doing it on the Varnish level, deciding whether the ads will be displayed or not, and so coding class and apply to allow for the space for the ad?
So the question was whether we could decide on the server side, say in Varnish, for example, whether we could save room for the ad, make that decision about whether we save room for the ad on the server side as opposed to the client side. We considered a lot of things, and using Varnish for a lot of things, especially edge side includes, is really powerful. The reason we didn't was our ad system needs to track impressions, and so when you request a set of ads, you're expected to show them. In order to find out if an ad was present, we didn't have a support for that without actually triggering an impression in our internal auditing. So without a way of maintaining the session from the server to the client, we wouldn't be able to have accurate ad tracking numbers. Because we would have made an ad request, figured out there was an ad, and then we need to make sure we get the same request on the client because they have to ask for it themselves. And that was too much of a challenge in terms of our current ad setup. It's a proprietary ad setup, which we only can make changes to as we need. So we thought about it, but in the end, it also complicates our Varnish setup a little bit. So we just really pushed it all client side. But it's an interesting notion. Now that we're doing this random chance, in terms of whether we make room for the ad or not, we could have done something similar and just duplicated what we display. We just have two cache entries for the same page, one without the space on the right, one with it. Again, we wanted to keep the caching simple, so we just did everything in the client.
I'm curious about that random or percentage-based layout, and how do you test that? How are you ensuring that you're not calling ads and getting bad numbers that way? Because sometimes you say you call an ad and you don't have space for it.
Right. So the question was about the percentage-based ad rendering. We found that it aligns itself really well when ad campaigns are structured with certain target goals in mind. We're well aware of how the ads are generally served through our ad system. So we tweak the numbers basically to see that we want to maximize that if there is an ad there, that it will show more often than not. And just because of the way the campaigns work, usually there's a remnant ad or a New York Times in-house ad that is the one that's going to get shown there, which doesn't have to be above the fold because we don't monetize that as much. But the idea is that it's very likely there will be space for an ad. Most of the time it should show just because of the ad impression is better. But it depends on whether there's an image there as well. Because if there's just a story, we don't have to move the image out of the way. So it's a complicated, there's a lot of business rules around how we arrange that top area of our site. And we're constantly tweaking the numbers to make sure that we maximize our revenue, but also our storytelling. Okay, so I think I have to wrap up. Thank you again for coming. I appreciate it.